Hello and welcome back to Science While Gaming. I'm here as I'm Mr. S, and hopefully you know that by now because you've watched a few videos. But if you haven't, welcome. You are of course always welcome to come and check out what we do here on the channel. I'm just explaining various science things in hopefully terms that are understandable and make sense. That's what I'm going for. As always, feel free to leave a comment if there's a thing you would like me to explain or you need clarification on anything at all. Just, don't be a jerk. That's all it is. Today's video, we are talking about chemical reactions. We're going to discuss kind of just the idea of them, what they are, how to identify them, what makes something a chemical reaction. Are there different types? How do you tell the difference? That kind of thing. That's what we're going for anyway. Whether or not you pick it up or understand it, that's going to be something you're going to want to pay attention to. As always, if you don't understand something, ask me, ask your teachers. If you want clarification, again, you never fully understand something without asking questions. It's the only way to really get to the point of a thing. So make sure you ask. It's the best way. So to introduce the idea of chemical reactions, we are looking at if you have something and you do another thing to it. So if you make it undergo some sort of change, is that change inherently chemical or is it not? So let me throw some examples at you. If we burn some wood, so if I had wood burners here to, produce energy, am I creating a chemical reaction? Well, the question that I want to answer then, the thing I need to ask myself on whether or not this is a chemical reaction is, am I producing something new? Because one of the main indicators that you have a chemical reaction is the production of a new substance. If you create a new substance, then yeah, you have a chemical reaction. There's no physical reaction that produces a new substance. Everything produces something new in that case. So the main one I want you to think about and remember is there a new substance produced? If the answer is yes, then you have a chemical reaction. There are some indicators of a chemical reaction that are fairly straightforward. Like production of a new substance, but there are some that are less obvious that you are creating or having a chemical reaction occur. One of which is production of a gas. If you produce a gas, you most likely have a chemical reaction, but that's not always true in the sense that if you are boiling water, you are obviously turning liquid water into gas. If you have made hard-boiled eggs, or if you've ever made macaroni and cheese, then you know that in order to do that, you boil water. When you boil water, you change it from a liquid to a gas. But does that mean you made a new substance? Is the steam that comes off the water still water? Is it still water? Is it still H2O? If the answer is, yeah, it's still H2O, then you do not have a chemical reaction. And the answer, of course, to that question is, yeah, you do still have the same substance, so you are going to be having a physical reaction. Changing phase, going from a solid to a liquid to a gas, anything like that, that is all a physical type of change. It's not a chemical reaction that's occurring there. So you can use production of a gas as an indicator of a chemical reaction, but you have to be very aware. Are you having this change occur because you are introducing energy, you're introducing heat, or is it because you've just combined two things together and it's producing what appears to be spontaneously? If it's appearing spontaneously, then you have a chemical reaction kind of occurring. And when I say spontaneously, I do mean like it just seems to kind of appear. It's an important thing to think about simply because you can have gases appear in times where it's just doesn't seem to be anything happening. There are definitely plenty of videos and examples to see online, or your chemistry teachers, I'm sure, are going to show you various experiments where you produce a gas by mixing substances together. And when you mix those substances together, without adding any sort of additional heat or anything like that, they will start to bubble. And if they are bubbling, then you have chemical reaction occurring. The other thing that is not a super obvious indicator that you have a chemical reaction, it certainly can be an indicator, but it's not 100% like if you see this, you have a chemical reaction. Generally, with these kind of indicators, you want to take them together. You want them to be, you want to have more than one of them. The last one I'm going to mention is production of, a color change. If you have a color change in a substance, often you have a chemical reaction. It's not always, notice I said often because it's not 100% of the time, but often you do have a chemical reaction. And you will know that you have this chemical reaction a couple of different ways, because if you take metal and you heat it up, you are producing a color change. I'm sure you've seen, if you've ever had a campfire or watched various shows where they have blacksmithing in them, you've seen these color changes occur in metal. So metal heats up, metal gets red, something that most people are familiar with. But that color change there, that red, that doesn't mean you have a chemical reaction that is occurring. And there's a reason for that. There's a fair bit of science that goes into it, but it's not important here. So because you can have a color change that doesn't indicate a chemical reaction, you have to wonder, okay, well, when does the color change indicate a chemical reaction? Again, it's kind of like a spontaneity kind of thing, like something that happens a little bit spontaneous. And that word does actually mean something within the realm of chemistry that's a little bit different than perhaps we're used to. I do keep using because that's what's going to relate to your brain best. If you are looking at something that's happening and you're not doing anything to it, you're looking at two liquids. You have two liquids that are clear and you mix them together and suddenly you have a liquid that is not clear. You have a chemical reaction. That's very likely that you have a chemical reaction. So a color change where you are introducing energy to the system, where you're heating something up, that's usually not so much a chemical reaction because you're introducing that extra energy. There's an explanation for the change in color. When you take two clear liquids and you mix them together and you have a sudden change in color, it seems to be a sudden appearance of this color change. That's kind of what I'm talking about when it comes to being spontaneous in the color change. So it's something that's relatively common. You'll see it quite a bit. High schoolers do a lot of different experiments where you see this change occur. So if you're wondering about what does it look like, well, that's you'll see it. It'll be there. It's guaranteed, almost guaranteed. I don't want to speak for your teachers. Almost guaranteed that you will do an experiment that does contain a chemical reaction like that. So I have no doubt that it's going to be seen. Not all chemical reactions are the same. You can have a chemical reaction, or it is a chemical reaction, when you burn wood. If we have a fire, you are producing gas, you're producing ash, things change color, you have several indicators that a chemical reaction is occurring, so you know you have a chemical reaction. But if you leave a bicycle out in the rain, or you've seen an old car and they start to rust, that car rusting, that is a chemical reaction. The formation of rust is a chemical reaction. So because of that, we have to be able to see that, well, the formation of rust is not the same as the formation of, the combustion of wood. So lighting wood on fire is not the same as a car rusting. So if they're both chemical reactions, then we must do something to separate them. And so in order to separate these chemical reactions, we actually classify them in different ways. There's going to be a follow-up video talking about exactly how to identify the different types of chemical reactions, but there are 5 different types of chemical reactions that we're going to see. Those 5 types are combination, which is also known as a synthesis reaction, decomposition, which, again, I will go into all of these in a separate video. So combination or synthesis, decomposition, single replacement reactions, double replacement reactions, and finally you have combustion reactions. Those are your 5 basic major types of chemical reactions. And you can classify every single chemical reaction that occurs in one of those categories. Sometimes they fit into more than one of those categories, but they will always fit into, at the very least, one of those. Yeah, like I said, I will cover that in a separate video. We are going to talk more. There's going to be a couple of videos about chemical reactions as a whole. So look forward to that, I hope. Hope you enjoy the videos. Definitely feel free to leave any feedback. You guys know the drill. Just, be a nice person. That's all I ask. It's not hard. It's a really easy task to do. Any last minute questions, comments, anything you want me to cover in a future video, feel free to leave that in a comment. Yeah, I think I'm gonna call it here because I can hear my puppy whining in the other room, and I'm gonna go take care of him. So I hope you enjoyed the video, and yeah, see you next time. Bye bye.